No, I mean, IMTS, again, if you've never been to IMTS, this is the kind of thing that you're going to get out of the show. You're going to have these interactions where you're going to learn a lot, not just about products and services, but about stories and narratives and motivation, all these kind of things. It's a business show. It's a lot of good stuff happening here. So it's really
you may have noticed that we are, that's right. Well, you may have noticed that we are standing here in a booth of one of our good vendors. Earlier today, I had the chance to chat with Guangnong Meng. He's the product manager for the industrial microscopy for the Scientific Solutions Group of Olympus America. And Guangnong showed me the Olympus Lex OLS 5000 3D laser confocal microscope. Fantastic piece of equipment, really interesting. And we're going to show it to you right now, so let's take a look. Okay, Guangnong, so what are we going to look at today?
So today we're looking at our most advanced laser confocal microscope from Olympus.
Okay.
So this can give you down to the single nanometer in a matter of the minute.
Really? Okay. And this is a 3D measuring system?
3D measurement, and people used to do this kind of measurement on other more advanced equipment, for example, the AFM, SEM, but those systems, one thing is more complicated, other things like take a long time.
The sample preparation,
the sample
SEM,
preparation
AFM,
and the data acquisition.
Okay.
For example, AFM, you just have to wait that scan to be finished. Sometimes take like more than days, whatever. But this one can get a larger field of view on 3D with very accurate data, down to as small as single nanometer level. Okay. So when you're talking about the quality checking, assurance, this is a very practical tool. Sure. I'm not saying that can be outperforms the other tools, but if you look overall productivity, time saving, and efficiency, and this would be a best choice, to do this. And nowadays, people need to look at the surface more and more carefully because of all the manufacturing, technology evolving a lot in the last 10 years.
Sure.
So people always want getting a better picture on their parts, make sure it meets the standard.
So show us, run us through it. Show us some of the things it can do.
Sure. So we just start up here. So what we are gonna do is we're putting a semiconductor chip there. Right now, here is overview of the chip at the lower magnification. Okay. I change the 50x. Okay. Then I set up some kind of the area. You can say this can automatically go to that area and find the best focus. But what it makes easy, it's gonna go through this 18 points, getting the data automatically there. So this part actually is also critical in terms of a quality check. So you can click the system on one button, then you do something else more valuable for you. For example, have coffee or think about more.
Right.
And after you're done with other stuff, all the data is already here, so you can review the data, decide which part you need to reject, and even more if you hook the system to your production line there. If you have some smart communication build on the product, just kick off the bad parts there, but that's the further step. Okay. But we just had one customer yesterday. He need to check this some fancy 3D printed particles, and he wants to check all the shapes. There's millions of them, and he was very impressed. We have this capability, so basically he can just set up the automation script there, and click one button, and have the machine run the rest of the stuff for him.
Well, I mean, so what we're seeing on the screen here, there's like you said, I think you said there's 18 dies or pads or something we're looking at there. Yeah. So it's already been pre-programmed.
It's already programmed
to locate those and measure each one of those.
Yes.
So once you set the routine up, it'll just step through all 18 of those and take the data.
Yes.
And I see when I look at the screen here, it looks like it's building up a 3D image.
Yeah, it's doing its optical tricks, scanning through, and figure out the height. For example, it's an example showing here. You can just automate it like 18 is not the limitation. You can set like maybe 10 million, whatever.
Okay, yeah.
Get this automated.
Okay.
And of course, if your parts are complicated, you want using one mode on one area, use like the other mode in the other area, it's also possible.
Okay.
So there's some kind of the automation script-based programming capability.
Okay.
So you can just specify those kind of functions depending on the area. For example, like on the tile 1, you want to use in the this 3D, conventional 3D morphology capture. On the tile 2, you want to look at this film thickness or like single line profile.
Sure.
That's all very possible.
Okay.
Yeah.
And you're doing, but that's after the data's been collected, right? So that's doing that on the fly, or you're collecting the data.
You're doing that on the fly.
On the fly. Okay.
Yeah.
All right.
So,
okay.
I mean, on the data analysis part, you can also build some kind of automation there.
Okay.
Like run certain kind of script through the data. For example, for the 3D data, it's important to get this kind of tilting correction.
Okay.
Finished. And also, if you look at the surface roughness, you have to apply certain filter conditions,
Sure.
stuff like that. All of those things can be automated.
Okay.
Yeah.
So, in terms of, let's say, inspection that you would do, and tell me if I'm wrong here, but if you can do an inspection real time, which is essentially what we're doing here, right?
Yes,
and
yes.
look and program it to look for what dimensional data or roughness data.
Yeah,
or,
dimensional data and roughness parameters.
Okay.
Once get into the roughness parameters can be complicated depending on the needs, but it's easier, if you know the parameter, key parameter, pre-program it.
Okay.
And tell the system, the parts didn't meet that parameter and kick out, right?
Okay. Show us the interface a little bit here. I mean, it looks like a very simple interface. It doesn't seem overly complicated. So what would let's say the average person who is going, it's already been programmed and everything, what would the average inspector, how would they use this?
So,
in terms of the steps they might make.
we're trying to make this whole interface more user-friendly.
Okay.
And you can say this is the live image, take care of the data acquisition, and you have the control, the key control of the microscope. For example, you're changing the objective magnification, stuff like that, and changing the modes here. And it's very straightforward to read out. And most of the very advanced feature you hide out on this kind of drop-down menu.
So the typical user is presented with a pretty simple control
yes,
panel. Okay.
Yes, very pretty simple. But if you need some advanced modes there, you can click on the drop-down menu and bring more advanced feature.
Okay.
Those features are also very intuitive, explained. For example, we are doing this kind of, we call it multiple area acquisition. You will have just that window, give you all the information you need. A user with some kind of a technical background pick up the system very easily.
Okay.
Especially for some younger generation, they even figure out everything in 10 minutes during we're talking about the system, and they took over.
They've already got it figured out.
Yeah, so it's very easy for the user to dive in deep.
And what's our right-hand screen here?
So right-hand screen here, we're showing the analysis window here. Just so you can, as it's doing the acquisition, right? And you have some time, and you want to think about how to look at the data, build the best analysis recipe. So this is separate program, improve the whole operation efficiency. So for example, you say, do I have some defects here or scratch here? I mean, I look at the different channels. Now I'm looking at the color channel, or laser intensity channel. Figure out what should I do, right?
Right.
And in this way, overall.
And you can do this at the same time.
It's not.
It's
Yes.
taking
Yes.
actually taking the data.
Yes.
Okay.
And for example, you can also like prepare the report for example, I'm doing like an example doing the in-plane measurement, like doing the point-to-point measurement. Right now, we look at the step height. I'm sorry, look at this distance, like about 100 microns in distance, and you can create a report.
So doing that all at the same time,
Yes.
and this is all off the same computer, right? So I mean,
This now, yes.
Okay.
But you can also like install this kind of analysis program in the other computer. You don't have to stay on the same machine.
Sure.
So for example, if your data acquisition environment is not comfortable, for example, in the clean room, you have to suit up.
Sure,
and,
right.
Sometimes you have to pay for the time.
Yeah.
You don't want to spend time and money on the analysis part. You can take the data out and do the analysis.
Okay.
Yeah.
Well, Guangnan, I appreciate it. This was the Lex OLS 5000, right?
Yes.
Perfect. All right.
Thank you.